Hi everyone. So today we are going to solve DILR set. This was of CAT 2020, if I remember correctly. And many of you in the comment sections have been mentioning that I increased the level of questions in terms of difficulty. So please note that I am only solving previous year questions right now. Right. So the difficulty level is completely random. Some of them might be easy, some of them might be difficult. So please bear with me. Okay, moving on to this particular set. This was asked in again CAT 2020 as I mentioned. So let's have a look at the question. 16 patients in a hospital, 16 patients, 1, 2, 3 till 16, must undergo a blood test for a disease. It is known that exactly one of them has the disease. So out of 16, 1 by 16, one of them has the disease and 15 do not. Exactly one, right? The hospital has only 8 testing kits and has decided to pool blood samples into 8 vials. A, B, C, D till G. The patients are numbered 1 through 16, vials are labeled to 1 to H. Following table, this table shows vials in which each patient's blood sample is distributed. Now, if a patient has a disease, then each vial containing his or her blood sample will test positive. What does it mean? So, if patient 1 has really have the disease, so B, D, F, H all will be positive and others would be negative, right? Even if others would not be negative, BD, all the 4 of a particular patient should be positive, right? If a vial tests negative, then none of the patient whose blood samples were mixed in the vial has the disease. So this line is very important, that if a vial tests negative, so if A is negative, then anyone having A, which is 9 to 16, none of these have the disease. Okay, I hope you get it. So we'll move to the first question itself directly. Suppose while C tests positive, A, E, and H is negative. So which patient has the disease? So read this line again. If a vial tests negative, these three tested negative, then none of the patient whose blood samples were mixed in the vial has the disease. So none of them having A in their uh, blood test will have the disease. So all these people have A, they don't have disease. E, people having E will not have disease. So this person will not have, this person will not have, this person will not have, this person will not. People will having H will not have disease. This, right? And now it is known that C is positive. So if C is positive, C is not there in patient 2. Only B, D, F, and G are there. So there should be C in. So only patient 6 is left. So our answer is patient 6. Patient 6. I hope you get it. That because C was positive, there were only 2 people left, right? 2 and patient 2 and patient 6. Only patient 6 blood sample had vial C, and others had AEH. So we just ruled out the possibility of them having the disease. Now moving to the next question. Suppose A is positive, D and G are negative. Then which of the following vials should we test next to identify the patient with the disease? So we know that A is positive. So someone from this particular row will have the disease. So we completely rule out this set of patients. Okay. Now D is negative. So anyone having D should not be positive. So these 4 have D. So we'll rule out these as well. Only the last 4 remain. G is negative. So patient 14 also doesn't have. Patient 16 also doesn't have. We have patient 13 now. Patient 15 now. Patient 13 is ACFH. Patient 15 is ACEH. Now we know that A is positive, right? Which should we check next to find out which of the patient has the disease? If we check C, both of them have C. If it turns out positive or negative, it will not help our case because both of them have it. Similar is the case with H. If we test H, if it turns out positive or negative, doesn't help our case. We will not know which of these patients have it. So what is the differentiating factor? F and E. So either we can test F or we can test E. So if E is positive, then patient 15 has the disease. If F is positive, then patient 13 has the disease. So we need to check either F or E, right? So we need to check E because F is not in the option. So our answer is option number 2, right? Moving to the next question. Which of the following combination of test results is not possible? So we'll see the first one. B is positive, C, F, H is negative. So if B is positive, I'm just seeing the first option first, okay? So if B is positive, then these people will have the disease. Now, C, if C is negative, then these people will not have the disease. If H is negative, this person will not have, this person will not have. And if F is negative, then this person will not have. We still have a patient 4. So in this case, P4 can have the disease, so it is possible, right? Now we will see option number 2. What is option number 2? A positive, G positive, D negative, E negative. So if A is positive, so anyone containing A can only have the disease, so these people will have it. Plus, it should also have G, so we'll just rule out people not having G, basically the odd numbers, right? Now D is negative, so this person does not have it, this person does not have it. E is negative, this person does not have it. We still have patient 14 left. Patient 14. So in this case, P14 will be positive, so it is also possible. Okay. Now let's check the other option. Other option is B is positive, D is positive, F is negative, H is negative. So if B is positive, it should contain B, so these people do not have it. This is our set which remains. D is positive, then these people will also not have it. 1 to 4 are the people who remain. Now it says F is negative, so F is negative, this person can't have it, this person can't have it. So we are left with 3 and 4. Now H is also negative, so this person can't have it. So we are left with patient 4. So again patient 4 is there. So this thing is also possible. So now automatically there is only one option left. So we can, without even checking, just mark the option and move on because we have checked the other 3 options. These are possible, so this should be our answer. But again we'll check. A is positive, E is positive, C is negative, and D is negative. So if A is positive, these are not people who are who will have the disease. E is positive, so we rule out people having F. People having F, we are left with 11, 12, 15, 16. C is negative and D is negative. Both of them has D, so 11 to 12 can't have it. Then C is negative, both of them have C, so these two also can't have it. So we are not left with any patient. No patient is left, but it says exactly one of them has the disease, and here we saw that none of them was left. So this combination is not possible. Hence, this is our answer. Option 4. Now moving to the last question of this set. So suppose one of the lab assistant accidentally mixed two patients' blood samples. So they mixed the patient's blood sample. So P1 and P2 is mixed, for example, and it is not vials that are being mixed. So please note that A and B are not being mixed. Patient 1 and patient 2 is being mixed. So before they were distributed to the vials. So which of the following correctly represents all set of possible numbers of positive test results out of the 8 vials? So we have to tell that which of the following correctly represent the set of all possible numbers of positive test results. So how many positive test results of the 8 vials can we get? We have to tell the set. What is the possibility? Right? So we'll see all the possibilities. So for example, we assume let P1 is the person who has the disease. P1 is the person who has the disease. Now you mix P2 and P3, P3's blood. Nothing happens, right? Because the person having disease is P1. So if you mix P2 and P3, none of them have disease. So there's no positive result for P2 and P3. You can mix P2 and P4. You can mix anyone. What will be the outcome? Unless and until you are mixing P1's blood with anyone, only the 4 vials with having P1's blood will test positive, others will test negative. Doesn't matter whom you are mixing, right? Only P1 is, if P1 has the disease and we are mixing P2 and P3 or P5 and P16, for example, doesn't matter, right? Unless and until you mix P1's blood with anyone, it does not matter. So 4 is a possibility. So we rule out this particular option because it doesn't have 4. So 4 is a possibility, right? Now we saw that 4 is a possibility. So if we check for directly for 6, we can rule out this option if there is. So we are not checking for 5 because it is common, right? So we will check for 6. Now we'll again assume that P1 is the person having the disease. Now for 6 vials to come positive, we'll have to mix P1's blood with someone who has 2 common. So that's how you will get 6 vials which will be positive, 4 of P1 and other 2 of any other person, Px, let's say 2. That's how you will get 6 vials, right? So we see how we can mix P1's blood with someone who has 2 common. So if we mix P1's blood, P1 is B, D, F, H. So these are positive for now. There are 4 things, 4 vials which are positive, B, D, F and H. Now B, D, F and H. We see patient number 10. Patient 10 does not have disease but will mix with P1. So all vials containing like having P10's blood will also test positive. P10 is having A, D, F and G. Now D and F are common. So now total number of vials total which are having positive would be B, D, F, H, A, G. So we have 6 vials which are positive. 6. So this is also not our option. Okay. So now we are left with option 1 and option 2. 4, 5, 6, 7, 4, 5, 6, 7, 8. So because 7 is common, we'll simply check 8. If 8 is possible, then uh, option 2 will be our answer. If 8 is not possible, then option 1 will be the answer. So we'll check 8. So again, assume that P1 has the disease. B, D, F, H are positive. Now we have to find such a person, Px, who has all vials different from P1. That's how you will get 8, right? 4 of P1, 4 from P1 and 4 from Px. If you mix their blood, all 8 will have the disease. Now BDFH has a disease. What is left? A is left, B is there, C is left, D is there, E is left, F is there, G is left. So we are is there someone with ACEG? Yes, there is patient number 16. So if we mix P1, just a second, P1 and P16, A2H, all of them will have disease, 8 people. So this is not our answer. Option 2 is our answer. 4, 6, 4, 5, 6, 7, 8. These are the possible set of all possible numbers of positive test results. So there's a possibility that 4, 5, 6, 7, and 8 vials will test positive if this was the case. Okay, hope you got it. If not, you can also comment and let me know. Thank you for tuning in.